Hi everyone, I hope you're all doing well and all are staying safe. Welcome to my YouTube channel Network Tech Zone. My name is Sanjana. In our previous video, we have configured static NAT using AutoNAT. The link of this video is given in the description box below. Today, we will configure static NAT using manual NAT. Let's understand some common differences between this AutoNAT and manual NAT. AutoNAT is also called as Object NAT and manual NAT is called as a TwiceNAT. In case of AutoNAT, we will be allowing the translations from the source address. But in case of manual NAT, we will allow the translation both from source as well as the destination. So that's possible in case of a manual NAT. In this video, we will be configuring bidirectional NAT, unidirectional NAT and a destination NAT. Let's get started with the lab. The topology is very simple. I have just taken the ASA firewall connected to a switch, and the switch is connected to one of the VPCs and to a router. And here the router we will consider as a router 1, and they are all located in the private network, and that's going to be inside network. And between the ASA firewall, we have R2, which is connected on the outer interface. So for the network, we got 10.1.1.0 with the /24 for the subnet mask, out of which .1 is assigned to VPC, .2 is assigned to the interface on the ASA firewall, and .1.3 is assigned to router 1. And for the router 2, I have got 192.168.29.1 and 29.2 is for the outer interface on the ASA firewall. For this lab, I have already pre-configured the IP address in order to save the time. So all this IP address that you're seeing on the diagram has been already configured. Now, for me to have a connectivity, since we got a different network here, right? So we also need to make sure that we have routing enabled. And I have not configured the loopback IP address. So let's go ahead and configure the loopback IP address on the router 2. I've not taken the home network here. I've just taken a router in this case, just imagining that this router is my home router. Okay, and you can imagine this loopback IP address is just like your 8.8.8.8, thinking that it's an internet. So our goal is we are going to connect to this 8.8.8.8, okay, from our inside private hosts which are present in the inside network with the help of translation and see if that can be reachable towards 8.8.8.8. Okay, so this is my R2 router. So I will configure the loopback IP address. So loopback one IP address 8.8.8.8 255.255.255. I would say the complete 255. Yeah. Yeah. No need of giving no shut because it's a loop back. So I'll just say exit. Save the configuration. Let's rename this to avoid confusion. So host name R2. Okay. Okay, so let me just increase the font size so that it's clearly visible. Let's configure SSH or Telnet, okay, for the router. I will go to the router, R2, line BTY 04, password hello, transport input all, exit, and enable password Cisco. And I'll just save the configuration. Okay. Let's move to R1 and configure the same. So on R1, line BTY 0 to 4, password is hello, transport input all, exit. Enable password Cisco. Okay. Yeah. So we have configured the transport input all command for so that you can use either Telnet or SSH for both the routers. But we also need to make sure that you have routing protocol enabled. And here in this lab, I will use router RIP, that is routing information protocol. So I'll go to one of the router, which is R1. So on R1, let's say router RIP network. So what is the network here? We have 10.1.1.0. Okay, no auto summary. Version 2. Okay, and I'll just save the configuration. Similarly, let's have RIP enabled on this ASA firewall. So on this ASA firewall, router RIP network. Here you have got two network connected. So 10.1.1.0. There's one more network that you see, which is 192.168.29.0. Okay, so version 2, no auto summary. So that's connected via RIP. I'll just save this configuration. That's done. So let's move to router 2. On the router 2, let's configure RIP. Router RIP network. Here we have only one network, correct? I'm sorry, we got two networks. We also have to configure this loopback network, yeah? And one more is this network, 192.168.29.0. Okay, and one more network, 8.8.8.8. So that's going to be auto summarized, right? So let's use no auto summary and with the version 2. Okay, and I'll just save this. That's done. Yeah, exit. If you want to verify, use the command show IP route. Okay, so you can see there's directly connected loopback. Okay, show route, show running. You can see the loopback IP address that's configured. Okay, and for Ethernet 0/1, we need to have the IP address configured. We have not configured this IP address yet on this. So let's configure that. Configure terminal interface Ethernet 0/1 IP address 182.168.29.1 and /24 for the subnet mask. Yeah, no shut. Okay. So now let's check. Show IP route. You can see that now it is seen. Yeah. So this router, which is router 2, is communicating to the 10.1.1.1.0 network via RIP. Okay, with the help of the routing protocol that we have configured. So the next step here is, let's verify if all these routes are present on all these 3 devices. Okay. Let us also configure access list on this ASA. So let's go to ASA. Access list out to in. So here we are configuring the access list for permitting the traffic from 8.8.8.8 to reach any host. Okay, so extended permit ICMP host 8.8.8.8 to any. This is only for the lab purpose. And for the lab purpose, since I have not taken the actual Windows computer, and since it's a virtual PC and a router, I'm using Telnet. Okay, usually SSH is more secure when you compare to Telnet. But just for the understanding purpose, I will be connecting to the other remote router using Telnet. Okay, so access list, and I will give a name. So access list out to in extended permit TCP, and the host is 8.8.8.8. Okay, and connected to our router. Okay, our router, which is R1, and the IP address on the R1 is what? 10.1.1.3 equal EQ via Telnet. Okay, yeah. So we also need to specify the access group. So access group out to in interface outside. Okay, let me just save this. And now let's check the routing configuration. Let's begin with router 1. On router 1, I will say, okay, we gave a password. So password for this is your enable password, and the enable password was what? Cisco. Okay, show IP route. Let's check the routing information protocol, and here it is. That's connected. Okay, we also have this 192.168.29.0 network. So we got 2 networks here. That is this loopback and this outside network. We are good on router 1. Let's move to ASA firewall. And on the ASA firewall, let's say show route. So we got the remote router 8.8.8.8, which is very good. We got this because we specified the complete mask. So it is /32. So that's the reason you're seeing the complete 8.8.8.8. Okay. So we're good on ASA firewall. Let's move to router 2. This is the router 2. Let's verify. So Ian, Cisco, show IP route. And there it is. It's you have the private network that you can see here. Okay, so we're good on routing information protocol. Our routing protocol looks good. Our access list also looks good. Let's try to see if you can ping from R1 to connect to R2 and see if that's working. Let's go to R1. And from R1, I'm going to try to ping 8.8.8.8. And that's working. That's because of the ACL. Okay. Okay. And now here, let's continue with the task. So let's do the first task now, which is called bidirectional NAT. Okay. So for the bidirectional NAT, we will give 2 IP addresses, one for VPC, one is for R1. Okay. So let me just make a note. So for the VPC, we will call this as a NAT VPC and map it to what? We'll map it to 192.168.29.99. Okay. And for the R1, we will NAT this to say NAT R1. Okay. And then we will NAT it to 192.168.29.100. Okay. Fine. So keeping this as our plan, since you already know that if you're using a static NAT, you will be having public IP address assigned for each of the internal host, right? So, and that's the reason I've taken 2 public IP addresses. Okay, imagining that this is a 2 public IP address. Yeah. So that's how we will configure bidirectional NAT now. Okay, let's move to task number 1. And let's go to ASA firewall. Configure terminal. Object network VPC. So for the VPC, we'll give a name VPC. And what's the host IP address for this VPC? Our host IP address is what? 10.1.1.1. Yeah. And we have one more object, that is object network router 1. Yeah. And what's the host name of this router 1? It is 10.1.1.3. Okay. That's done now. So our next step is what? Object network NAT VPC, right? We need to map this VPC. So I'll just take a name called NAT VPC. And for NATing this VPC, let's take a host. Okay, and we are going to NAT it to what? 192.168.29.1. Oh, sorry, let's take 2099. Okay. And next step, we have one more there. So that is object network NAT R1. And we are going to NAT it. Yeah. So we're going to NAT it to what? 192.168.29.100. Okay, so this is configured now. Let's configure the NAT. Configuring NAT, just exit out. NAT. Inside. To the outside. So source, we're using StaticNAT. So I will choose static. And for VPC, we will give it to NAT VPC. That's the NATed IP address. Okay. And for the inside, we have one more for R1. So inside, comma, outside, source, static R1, and that's going to have NATed R1. So NAT R1. Okay. Very simple configurations. So let's verify. Show NAT details. You're seeing the hit counts are all 0 now. And you can see the IP address for this 1.1.1. Okay. This 1.1.1 on the VPC, okay, is getting translated to 29.99. That's what you can see here. Okay. And similarly, the R1, which is 1.3, okay, is getting translated to 29.100. So there is no hit count so far because we have not initiated any traffic. Okay. Now, let's go ahead and run some ping and see how the hit counts appear. So I'll go to inside R1. Okay. And then I'll try to ping 8.8.8.8. You can see you're able to reach 8.8.8.8 with 0% packet loss. You can see the success rate is 100%. Okay. Similarly, let's also try to telnet from router 1. Okay. From router 1, let's see if you can telnet 8.8.8.8. It's working. It's asking for the password. And password, you can just say hello. Yeah. Enable password, you know that is Cisco. And there it is. That's working as well. So if you want to see the connectivity from R2 on the R2, you can just say show connections. Show users. You will be seeing only the public IP address, not the actual IP address. That's what you can see here. So you are seeing 29.100, which means the public IP address of the R1. Okay. If you would not have the NAT configured, then you would see the actual private IP address. And that's the beauty of NATing. So let's also check from the router outside. Okay. From the outside router, we'll try to ping this public IP address. Okay. Let's say I'm on the router 2, which is this router 2. Let's try to go to ping this public IP address of my VPC. I will ping. So ping 192.168.29.99. Okay. With the source loopback IP address. So what I'm doing, I'm trying to reach this public IP address from my loopback IP address. Okay. Loopback 1. And you can see it's reaching. So that means you're reaching the VPC. Okay. So let's run some debug command and see how the packets are flowing. So I'll go to router. I'll just say debug IP ICMP. Okay. Just because I want to see how the traffic is appearing on this router. Okay, we are on a router 2. Let me just exit. Okay, I'm back to router 1. So debug IP ICMP. I just want to make sure that when I initiate the traffic to connect via the public IP address for R1, you should be seeing the flow of traffic on this R1. Okay, so I'm on the outer router, which is router 2. And from the router 2, I will say ping. And I want to reach this public IP address of R1, which is 192.168.29.100. Okay, so 192.168.29.100. Okay, with the help of my loopback IP address, and let's see. Okay, do you see the packet flow here? So we are able to reach router 1. Okay, so you're getting the reply. You're getting the reply from 10.1. You're getting from the source IP address 10.1.1.3 towards the destination 8.8.8.8. Okay. Similarly, on the router 2 also, I can see echo reply is received. Received from where? From the source IP address. It's not showing you the actual private IP address, but it's showing the public IP address. Okay. And you're getting the reply from where? The public IP address to your destination IP address 8.8.8.8. Okay. So that's how the bidirectional NAT works. If you also want to verify the telnet from outside to inside, you can still do that. So I'm on a router 2 still. Okay. So let's say telnet 192.168. Let's move to access this router 1. So I'll say 29.100. Okay. So 29.100. Okay. With the help of my source IP address. Source. 1 second. Telnet 192.168. What's the public IP address of the R1 we netted? It's 100. Okay. With the help of my source interface, which is 8.8.8.8, which is the loopback IP address. So it is working. It's asking for the password. So password is what? Hello in lowercase. Enable password, and the enable password is Cisco, and that's connected. Okay. So when you are trying to see from the router 1, so from the router 1, I will run the command show users. Okay. Since this is a bi-directional NAT, I've not NATed the destination. Okay. So when you're trying to use the show users, you will see the 8.8.8.8. The actual IP address is seen because we have just used the StaticNAT for the source, not for the destination. So you will be able to see the actual real IP address of the destination. Okay. But when you're trying to tell it 8.8.8.8 from your router 1, and when you give the show users command on the router 2, you will see public IP address. Okay, so that's about bidirectional NAT. So in bidirectional NAT, both the NAT rules are applied and both objects will be translated. So connections between two objects will be allowed in both the directions. Let's proceed with the unidirectional NAT now. Okay, so before we go to unidirectional NAT, you can also see the hit counts. So if I say show NAT details, that's how you can see the hit counts, which is indicating that translations are happening. Okay, so if you want to see another hit count, if you just go to the router here, so I'll say ping 8.8.8.8, you will see increase in the hit count. Check this out. Show NAT details. Okay. See, the hit counts are increased. Earlier it was 8 and 8, now just 10 and 9. So the hit counts are increasing. So that's about bidirectional NAT. Let's move to unidirectional NAT. So why do we use unidirectional NAT? The unidirectional NAT can be used when we are it can be used as part of our security policy to make sure that unsafe network cannot access to our internet network. Okay, so to disable this bidirectional NAT, which we just configured, I will go ahead and remove the configured NAT, and I will be using a unidirectional command. So I'll just go to make changes on the ASA firewall, and I'll say show run object. Okay, and I'll just use show run NAT. Okay, I'll just remove this command. Okay, I'll just copy this now and I'll just say unidirectional. So I have disabled the bidirectional NAT now. Only on the source, okay, I would like to have the NAT configured. But anything which is coming from the destination, that's going to fail. That's the logic behind this command. So let me just exit out. Okay. Now show NAT, I'll just say clear xlit. Okay. Let's see hit count what is showing. It's 0 here. Okay. For R1. Don't worry about this VPC because we have not done any changes. So don't worry about that. So let's see. So now it's showing 0 for the hit counts for the R1. Yeah. So now let's go to R1 and I'm going to try to reach 8.8.8.8. You will see the packets are going to fail. Why? Why do we see success rate is 0%? The reason is because the echo replies, which is coming from outside, is blocked because I have said unidirectional. So anything which is coming from destination or the other side is getting blocked. Similarly, however, since there is no reply echo packets, right, from coming for telnet, your telnet will work. So from R1, I can access our 8.8.8.8 with no issues. Let's see. So Cisco, okay, the password was hello, right? HELLO. Okay. Enable. Cisco is my enable password. So you can see it's working. Yeah. So you have access to the R2. Now let's see on R2, show users. You will see the, oh, okay, we are on ASA firewall. Let's go to router 2. So if you say show users, right, you can see the public IP address. Okay. Yeah. But from the outside, you can't telnet. So 192.168.29.00. Not possible because I did not specify bidirectional. I have only said source and it is unidirectional. So nothing comes from the outside. So but still, let's try and see the source interface, my loopback IP address, which we did earlier for bidirectional, and that was working there, but here it will not. So let's check. It's trying, it will try, and fails. So it's saying connection timed out, remote host is not responding because this is not a bidirectional NAT. All right. So even if you're trying to ping, that fails. 192.168.29.100. It's failing. And definitely, let's verify here. It counts show NAT details. You're only seeing the translation hit counts, but you will not be seeing the untranslations happening at all. Okay. So this is about unidirectional NAT. But let's see if you want to remove that unidirectional NAT. I'll just go to ASA, show run NAT details. I'll just remove this. Configure terminal, no. Okay. And I'll just keep it back the way it is. Show run NAT now. Okay. Now we are back. Try to ping from outside and see the difference. Show run NAT. Let's check the hit count now. Okay. Show NAT details to see the hit count. So it's 0 on down translations and 0 here. Okay. Now, from the outside, I will try to use the same command. See, that's working. This is password is HELLO, enable password. Cisco. Okay. You got access to R1. Show the same command. Show NAT details. You see the hit count? Yeah. Now, I'll try to ping. Ping 192.168.29.100. This has to be with the loopback IP address. So ping. Okay. We'll have to use the source interface from loopback 1. Let's just give some time. So ping 192.168.29.100 source interface loopback. .100 source interface loopback. So that's working. So what we understood here is when you have bidirectional NAT, you would be able to even have connectivity from both the destination and source. But in case of unidirectional NAT, we are trying to disable this bidirectional in the direction that we wanted. And here in our lab, we have just enabled for the source. But anything which is coming from the destination, that's going to fail. Okay, so that's what the differences between bidirectional NAT and unidirectional NAT practically. Let's also understand destination NAT. So let's check the ASA hit counts here first. Show NAT details. Earlier was 6 and 1, and now it's 12 and 3. That means it's increasing, which is good. So that means that the translations is working fine. So let's move ahead and configure destination NAT. Destination NAT is very simple. I would like to NAT R1 to 192.168.29.100. But I will be keeping 8.8.8.8 the way it is. That is, I'm not going to change the destination. Okay. All I want is just a translation of my source IP address to public NAT and keep the destination IP address unchanged. So I will go ahead and see what configurations we have for the NAT. Show run NAT. Okay, so I'm only concentrating on this R1. Okay, don't worry about the VPC. Let it be the way it is. So on the router 1, I have this IP address, this command for the NAT. That is, I have bidirectional NAT. Okay, so let me just clear this. Okay, and for the destination, I need to create an object. So let's create object network destination. So I'll just give a word DEST and host. Host I have 8.8.8.8. Okay, that's all. Okay, now let's go ahead and configure destination NAT. It's very simple. So I'll just exit out of this. Okay, so NAT from the inside to the outside. Source static the inside source host, my NATed IP address. That's because that's what I want. That's my goal. I want to NAT the inside host to a public IP address. Okay, which is nothing but your 192.168.29.100 and destination static to my mapped IP address. So if you just give question, you will see specify object or group name for mapped destination. So since I am not going to change that destination, I want to keep the destination map IP address the same. So I'll just say DEST. That is 8.8.8.8. Okay. The next command, real destinations. Real destination is of course 8.8.8.8, which we don't want to change. So that's all the command that's configured for the destination NAT. Now, let's see the hit count show NAT details. It's showing 0 and 0 for now. Okay. And if you see the source, which is nothing but my R1, I'm going to translate that to a public IP address. But for the destination, which is 8.8.8.8, I'm just keeping it unchanged. I'm not going to change that. That's the destination NAT. Now, I would like to go ahead to a router. On the router 1, let me also enable debug command. Debug IP ICMP. Okay. And now let's say ping 8.8.8.8. That's going to work still. And your destination, of course, you're getting reply from 8.8.8.8 to your own IP address on a router, which is 10.1.1.3. Okay, so that's working, which is good. Let's see telnet. So I'm on router 1 and I'm going to telnet 8.8.8.8, okay, and see if that's working. It's asking for password and my password is HELLO, hello, and enable password is Cisco. And let's check show users. You're only going to see the public IP address for the source. And that's what you see here. You're seeing the public IP address because we have changed the source IP address to be NATed, right? To 192.168.29.100. And that's the reason you see this, okay? With the help of destination NAT. And let's see with the from R2, let's say telnet to public IP address 192.168.29.100 with the help of source interface loopback 1. So it's asking for password and password is Cisco. Okay, so password was hello, HELLO. Okay, I'm sorry with this. So enable password was Cisco. So let's say Cisco is the enable password. So we are now in router 1. So we got access remotely from router 2. So we are on router 1. Let's check the connections. So exit. So show users. So on R1, I'll say show users. And since we have not changed the destination, you will still see 8.8.8.8. Okay. Yeah. So let's go back to R2. And if you want to ping, let's say, I will say debug IP ICMP. Okay. And if I want to ping this public IP address via loopback 1, so 192.168.29.100 is the public IP address of R1, right? So source interface loopback. Okay. And you can see the reply is coming from, you're getting the reply with the destination 8.8.8.8. So that IP destination IP address is unchanged. Okay, so this is about destination NAT. I hope that this video has been informative to you all. Please don't forget to like and subscribe. See you in the next video with static PAT. Thank you for watching.